Recording? Yes, it is. Okay, how are you doing? Good, great, awesome. So we'll continue with what you have started like last time. Anyways, what did we do last time? Derivative rules, right? Okay, so we'll start with, remind ourselves of the rules we have seen last time. What are they? Remember, like the sum, if f and g are differentiable, then f plus g prime is equal f prime plus g prime. F minus g prime is equal f prime minus g prime. C f prime is c times f prime. C is a constant. Let's see if this can be listed, or it will fall. False. Okay, what as well? Maybe let me write them on the other side. The derivative of a constant is 0, constant. The derivative of, the derivative of what? Let's see. Of what did you see? Power law, right? The derivative of x to the n is n x to the n minus 1, n a real number. Did we see anything else? No? Did we? What is it? Exponential. Thank you. The derivative of e to the x is e to the x. And before, you remember in one of the lectures, we have seen that the derivative of cosine x is what? The derivative of cosine is minus sine x. And the derivative of sine x is cosine. Do you remember this? We have derived these using the definition of the limit. Let me see. Working? Yes, it is. Okay, it's good. Using definition of the limit and what as well? And the fact that sine h over h goes to 1 as h approaches 0. Okay? Great. So far, so good. Any questions on this? No? Great. Okay, now we'll see the product rule. Maybe I don't know if I should prove it or not, but yeah, okay. Let us look at the derivative of a product. What is fg prime? Okay, we will show that fg prime is what? Is f prime times g plus g prime times x. Okay? So, what does this mean? If you want to take the derivative of a product, you differentiate the first term, multiplied by the second term, plus you differentiate the second term, and you add the first term, and you multiply by the first term. Is that clear what this means? Everybody, is that clear? Okay, should we prove it? Let's see if we can prove it. Proof. I need the limit as h goes to 0 of f of x plus h times g of x plus h minus f of x g of x over h. And how do I proceed here? Well, let me try one thing here. I will let an extra f of x appear here. Now, if I let an extra, or if I subtract f of x on this side, what should I be adding? I should be adding f of x times g of x plus h. You agree? Yeah? You guys see that? Now, minus. H. Just one second. Let me try to do it on. Okay, that's good. Minus. Sure. Yeah. Okay. Do you agree with this? Everybody, do you agree with this? Do we see that? Everybody, do we see this or not? Any questions on this? Now, let us rewrite this more nicely. This is the limit as h approaches 0. Let me write this down as f of x plus h minus f of x over h times g of x plus h, right? I didn't do anything wrong here. Plus, let me factor an f of x from these two terms. So what do I get? I get f of x, g of x plus h minus g of x over h. Do you guys see this or not? I rewrote this in this way. Do you guys see? Yeah? Where? In the second one here? Okay, factor out an f of x. You mean this one here? This one? This g of x?
From the first equation, what happens to g of x?
It's here. Right? Do you see that? Okay, so let's start with this. I need the derivative of f times g. It's f of x plus h times g of x plus h minus f of x times g of x over h. Right? That's the limit I'm after. Agreed? Great. Now, I subtracted f of x here. Okay, I just opened the bracket and I subtracted f of x. Now, in order to balance things out, I just have to add the term that I have subtracted. Great, and this term is here. Okay? So far so good. Now, you can bring the h here, right? And multiply by g of x plus h. And then you factor an f of x out from here and here. You get g of x plus h minus g of x over h. And then you can evaluate the limit. What is this limit? You can really use the limit laws here. F of x plus h minus f of x over h. What is that? This is just f prime of x. Now, as h goes to 0, where does g of x plus h go to? G of x. Why is that? Because g is continuous at x. Why is g continuous at x? Because g is differentiable, right? Then, I have an f of x here times g prime of x, okay? G and f are continuous since they are differentiable. Okay, everybody, are we good? Everybody, any questions on this? Yes? Where?
Like on the top.
On the top, I just made this transformation, right? Why did I do that? Just in order to let the derivative of f appear. Okay? I mean, the guy is my equality still true?
Yeah.
It is true. Okay? So I did not violate any rules of math here. I subtracted an amount and then I added it back. So that's fine. Yes?
Will we ever be able to do this in a question?
Why not? Yeah. Okay. Any questions? Any questions? Yes?
I'm sorry, I'm having a really hard time understanding.
Guys? Yeah.
You just take f of x away
And then you add it back.
I don't understand.
You don't understand why we did this, or
No, how you did it.
how I did this? Okay, so I subtracted f of x times g of x plus h, I agree. Right? You have a times b, okay? Subtract 1 from a, and then multiply it by b. Or let's say, subtract 2 from a, and multiply it by b. What do you have to add to balance it out? So that you get a times b. You subtracted 2b technically, right? And then you add 2b, and then you get to c. Okay? I subtracted f of x inside the bracket. In order to balance it out, I have to add f of x times g of x plus h. Okay? And I did this just so that I let the derivative appear. Okay? Yeah?
How do you decide what is subtracted from f?
Practice. Okay? I mean, you need a derivative to appear. You could have done the same thing. You could have subtracted g of x from g of x plus h. It's going to be the same idea. Okay? Great. Questions? Anyone? Great. Awesome. Maybe that's a derivative. Let's add this one here. F g prime is f prime g plus g prime f. Let's add one more. I mean, I'll keep these ones here, okay? I'll just keep these ones here. I'll try to work on this. Okay, now we'll look at the derivative of 1 over f. And we will show that this derivative is equal to minus f prime over f squared. So, proposition, let f be differentiable at let's say at the point A, and suppose that f of A is non-zero, then 1 over f, the reciprocal of f, is differentiable at A, and 1 over f prime of A is minus f prime of A over f squared of A. This is called, by the way, product rule. This is called product rule. Okay, now this is called reciprocal rule. I don't know what you call it. But anyway, let's prove it. What? Oops. Yeah, great. What do I need to show here? I mean, let's use another definition, actually. Let's use the other definition of the derivative so that you can practice it. I will need to look at the limit as x approaches A of 1 over f of x minus 1 over f of A over x minus A, right? This is what I need, right? I need the derivative of this function of 1 over f at A. Great. I plug in the top, I get 0 over 0, so I have to rearrange the top. That's not bad. Okay, let me do it quickly. I just rewrite everything under a common denominator. F of A, f of x. Is that good? So let's see, f of A minus f of x over f of A, f of x over x minus A. Let me write it in a nicer way. So I have f of A minus f of x over x minus A times 1 over f of x A. As x goes to A, this limit is minus the derivative of f at A, right? You guys see this?
Yeah.
The derivative is f of x minus f of A over x minus A as x approaches A. Here I have minus the derivative. So this is minus f prime of A. Now, here what do I have? I have an f of A here. As x goes to A, f of x will go to f of A because f is continuous at A. Why is f continuous at A? Because f is differentiable at A. Okay? Since x differentiable at A implies f is continuous at A. Okay? So hence we have proved this. Let's add one more here. 1 over f prime is minus f prime over f squared. I think we'll have space for one more. Could we erase here? Did you guys write this down or? Yeah? After the last step? Where?
The last limit.
Here is good? It's good here? Oh, here's not good. Okay. You have f of A minus f of x over x minus A as x goes to A. If you had f of x minus f of A over x minus A, what would that limit be? Would be f prime of A. Do you agree? You have f of A minus f of x over x minus A, so this is minus f prime of A. Everybody, are we good? And then f of x will go to f of A, and f of A is 6. Yes, sir. Solve the product rule. Isn't this?
Isn't this f to the negative? What over f to the times the negative 1?
Where? Here? Yeah, but this is only x. This is not f of x to the negative 1. Okay? You see what I'm saying? Any questions? Yeah?
I'm sorry, could you explain the thought from like f of a minus f of x over f of x?
Over x1.
Like, how do you get like that? Like that first step, I still get it.
From here to here?
Yeah.
This is good.
Yeah.
Okay. Bring the f of a, f of x down. You can do that, right?
Oh, yeah, that's right.
Okay? And then you keep this, right? This is just a over b over c. What is that? This is just a over c times over b. Okay? Yeah?
I think it's the
f8 squared at the bottom. F of a is f of a, right? F of x will go to f of a. So you have f of a times f of a, which is f of a squared. That is the same. Okay? Guys, someone's asking a question? Yeah?
Why is this
Oh, because the derivative is at a. X is going to a, right? X is a variable. Okay? Great. Let us move on to the quotient rule. Now let's look at f over g prime. Now how do I proceed? How do I find this derivative? One way to do this is to start by the definition, right? Another way is to write it as a product. F over g. What is f over g? It's f times 1 over g, right? We agree? Everybody, do we agree? Now let me prime this. Take a derivative. This is just f prime times 1 over g, right? Plus 1 over g prime times f. let's write this. So this is f prime over g plus, what's the derivative of 1 over g? This is minus g prime over g squared plus minus g prime over g squared times f. Let me put everything under a common denominator. What do you get? You get f prime times g minus g prime times f over g squared. Provided g prime, g is non-zero. Okay? This is called the quotient rule. I'll write it here. Okay. F over g prime. This is just f prime g minus g prime f over g squared. Okay, sorry if you can't read that. All of these formulas you should have memorized. Okay, you should memorize these. We will do some practice questions, and after the practice, you will have them definitely. Yes. You may have to. I may have to prove them. Yeah, that's fine. Yeah. Provided g. Yeah, this is g. This is I raised the prime. Okay. Is that what you meant? Yeah. Okay, great. Let us do some practice questions on differentiating. Or, wait a second, should we do, okay, let's do something actually. Let's look at the derivative of trig functions. So what are the trig functions? I have cos and sin, okay? I have cosine and sine. Now, if I want to take the derivative of tan, what is tangent equal to? It's sine over cosine. So what can I do here? I can use the quotient rule, right? This is called the quotient rule. Quotient rule. Let's do that. Now, do you have to memorize the tangent? Personally, I don't memorize them. I derive them every single time. But, I mean, you can memorize them definitely. Great. Let us look at derivative of tan. What is tan x equal to? The derivative of tan x is equal to the derivative of sine x over cos x. Everybody, do we agree? Okay. What's the derivative of f over g? It's f prime times g. Numerator, the derivative of the numerator, which is sine x prime, times g, minus the derivative of the denominator, which is the derivative of cosine x, times the numerator, sine x, over the denominator squared. Okay? So far so good? Is that clear? Everybody, any questions on this? Is that clear? Okay, now, how do I proceed here? What's the derivative of cos? The derivative of sine, sorry. The derivative of sine is cos. So I have cos x times cos x minus, what's the derivative of cos here? The derivative of cos is minus sine. Do you agree? Yeah. So I have minus sine x times sine x. Should be consistent how I write my x's, over cos squared x. Okay. Let me write here. Now, what do I get on top? I get cos squared x, sine x times sine x is sine squared, minus minus becomes plus, so I get cos squared x plus sine squared x over cos squared x. What do I get? I get it's 1 over cos squared x, which is secant squared x. Okay? So the derivative of tangent is secant squared. Okay? Maybe we can add this here. Okay. Let's do one more. We did tangent. What should we do? Or maybe let's try the derivative of let's try the derivative of cosine. Very good. Okay, how do I start? How do I start the derivative of cosine x? How do I start? What is cosine? It's cosine over sine. So cosine x is cosine over sine. So cotangent x prime is cos x over sine x prime. How do I start then? What rule do I use? Quotient rule. Derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. What is cosine? The derivative of cosine is, this is, the derivative of cosine x is minus sine x, right? So it's minus sine x times sine x, right? The derivative of sine is what? Sine x. The derivative of sine x is, everybody, the derivative of sine x is cos x. I have a cos x here over sine squared x. Great. So what do I have? I have minus sine squared x minus cos squared x over sine squared x. Great. What is the numerator in that case? Minus sine squared minus cosine squared. What is that equal to? Everybody? It's negative 1 over sine squared x. So it's minus 1 over sine squared x. This is minus cosecant squared x, right? The derivative of tangent x, the derivative of cos x. Okay? Great. Let's do one more. Let's look at the derivative of secant x. Okay? How do I find the derivative of secant x? How do I write secant? It's 1 over cosine. And what rule do I use? I use this reciprocal rule, right? I mean, this one here, my memory starts to make mistakes. So every time I want to differentiate secant, I rederive it. Okay? It's better to be safe than have it memorized the wrong way. So what is secant prime of x? This is just 1 over cos x prime. What is this? This is minus the derivative of cos x over cos squared x. What is cos x prime? Derivative of cos x, what is it? Minus sine, right? Just look at this. Cos x prime is minus sine. So minus sine x over cos squared x. So what is that? It's sine x over cos squared x. This is just sin x over cos x times 1 over cos x. You can write it in what way? It's tangent x secant x. Okay? Derivative of secant is secant times tangent. I messed it up. Anyways, we have it memorized now. The derivative of tangent x is secant x. The derivative of secant x is tangent x times secant x. Okay? I'm going a bit fast because this would be just an application of the rules. We're going to do more applications now. Okay, are we good? Everybody, are we good? Okay? These are just derivative rules. Let us do more examples. Maybe I'll pick some from the book. Okay. Great. Find the derivative. Okay, everybody. Awesome. Let's start. Yeah, I'll just pick up my own example. Y is, let's see, cos x plus sin x plus x squared. How do I differentiate that? This function is a sum, right? The derivative of a sum is just the sum of the derivative. We agree or not? Yeah. So what is that? It's just y prime is equal to what? Y prime. What's the derivative of cos, everybody? Minus sine. The derivative of sine? Cos. Very good. The derivative of x squared? 2x. Awesome. Okay? So now you don't have to write every single prime. Okay? If you can spot it quickly, it's going to be faster. Okay? Everybody? Are we good? Let's do one more. Y is x squared, let's see, tan x plus, e to the x. Here, what is the operation? The final operation is a sum, right? I'm adding two functions. So far so good? Okay, so y prime, maybe let's write one more step here. Y prime is just the sum of the derivative of these two functions. You agree or not? So far so good, everybody? Now, what is the derivative? The first term. The second term, can I differentiate it easily? What's the derivative of the second term? E to the x. So the second term I don't have to worry about. The first term, what is the first term? Is that a function that I know the derivative of immediately, or it's an operation of building of two functions? It's an operation. What is this operation? This is a product. So what rule do I use for the second one? Everybody, the product rule, right? Everybody, are we good? Okay. Let's differentiate the... Should we write the steps, or we could skip? We could go a bit faster. Write the steps? Let's write the steps. Some are saying yes. So, x, the derivative of x squared tangent x, what is that? You differentiate the first term, you keep the second one fixed. Plus, you differentiate the second term, and you keep the first one fixed. And then you add the derivative of e to the x, which is e to the x. What is the derivative of x squared? 2x tan x, great. What is the derivative of tan x? Secant squared, awesome. X squared plus e to the x. Okay, let's do more. Y is 2x plus 1 times e to the x plus 2. Yeah? Yeah. Exactly. But here in that case, it's going to be a bit different. But sure, yeah. Okay, great. Let's look at this one. Now, what is this? What is this thing here? This thing is a product, right? So when I differentiate this, I have to differentiate it as a product. When I look at the product, y prime, how do I differentiate y? The derivative of the first one times the second one plus the derivative of the second term times the first term. Great. Now, what's the derivative of 2x plus 1? 2. Y prime is 2 times e to the x plus 2, right? The derivative of e to the x plus 2, what is that? It's e to the x, very good, times 2x. Okay? Everybody, are we good? Is it clear? Everybody, is it clear? Let's do one more. What is y prime? Everybody, what is y prime equal to? Yes?
So the last one, would you want to simplify further?
We could do that. Very good point. Let's do that. This is just 2x e to the x. 2x e to the x plus 3 e to the x plus 4. Okay? Did I mess it up? I think it's good. Plus 4 e to the x, sorry. Plus 4 e to the, no, plus 3 e to the x, yeah. Plus 3 to the x plus 4. Okay? Great. How do you differentiate this one? What is the operation here? It's a product. So I have to use the, everybody, I have to use the product rule. What is y prime? Thank you. It's 2x plus 1. Prime times 3x plus 2 plus 3x plus 2 prime times 2x plus 1. What is that equal to? Derivative of the first term. What is the derivative of the first term? Everybody? 2. Are we good? Yeah, we're good. Yeah, the derivative of the first term is 2 times 3x plus 2. Derivative of the second term is 3 times 2x plus 1. Let us simplify this. So what do I get? I get 6x plus 6x, so I get 12x, right? 12x plus 4 plus 3 plus 7, right? So how many x's do I have? I have 3x plus 7. Okay? Yeah, are we good? Now, let's look at one thing. If I had expanded this product, right? If I had expanded, I would have 3 terms, right? Or 4, that you can combine them into 3 terms. Should I be getting a different answer if I differentiate? No. Let us check this. So if y is equal to 2x plus 1 times 3x plus 2, note that y is equal to 2x plus 1 times 3x plus 2. What is that equal to? Expand that, what you get? You get 6x squared plus, let's double check, plus 7x plus, right? Everybody, do you agree? Now, if I differentiate this as a, should I differentiate it as what? This expression. What is the operation here? It's a sum. What is the derivative of this function as a sum? So y prime, the derivative of 6x squared, the 2 goes down and I reduce the power by 1. So I get 12x. The derivative of 7x is what? 7. The derivative of 2 is 0. Did I get the same answer? Okay? So whatever operation you use, you're going to get the same answer. Okay? But sometimes one operation is easier than the other. Okay? Any questions on this? Any questions? If you have questions, I think it's time to ask. In the back? Here? No questions? Are we good? Yeah? Oh, we're good? Okay, awesome. Well, let's move on. Okay, let's differentiate y is equal to x over x plus 3. What is the operation here, everybody? Is saying it's a quotient. So what should I be using here? I should be using the quotient rule. How do I differentiate this? Y prime is equal to what? You differentiate the numerator to x prime multiplied by the denominator minus, this minus is very important. You differentiate the denominator multiplied by the numerator over the denominator squared. What is that equal to? Y prime. What is y prime equal to? The derivative of 2x, everybody, the derivative of 2x is 2, right? So it's 2 times x plus 3. The derivative of x plus 3, everybody, 1, yeah? Are we good? Minus x plus 3 minus 1 times 2x over x plus 3 squared. And what do I get? The 2x goes away, so I'm left with 6 over x plus 3 squared. Okay? Are we good? Yeah, we're good? 100%? Yes? Yeah, in general, when it's easy, simplify for you, okay? And when it's easy, it's your judgment. Why is that? Because if you have a multiple choice, I will probably give you a simplified answer as options. So, like, it's better to get it simplified. Okay? Great. Let's do one more. Well, let's do a few more, actually. Let's look at y. Let's look at this derivative. Okay, what do I have here? I have a quotient. So what rule do I have to use? Quotient rule. Okay. Well, let's write it here. Y prime, what is y prime? It's the derivative of the first term, derivative of the top, the numerator, times the bottom, minus the derivative of the bottom times the top over e to the x plus 1 squared. Yeah, that's good. Okay, what's the derivative of e to the x? E to the x. So I have an e to the x here, times e to the x plus 1, Derivative of e to the x plus 1, everybody, what is that? E to the x, right? You see that? So it's minus e to the x times e to the x over. Expand that, what are you left with? The e to the x times e to the x minus e to the x will cancel out. You're left with e to the x over e to the x plus 1 squared. Are we good? Everybody, we're good? Yeah. No, this is clear. Yeah. You should do it this way. Maybe we have time for one more. Let's try something nice. Okay, let's look at this derivative. What is y prime, everybody? What is y prime? Let's try and do it. Here I have a sum, right? So y prime, let's try and do it a bit fast here. Should we do it a bit, try to do it fast? Yeah? Let's try to do it a bit fast. I have a sum of two terms. Each of them is a product, right? Let's try to differentiate the first term. So I have to differentiate the sum. So it's the sum of these two derivatives. So let's differentiate the first term. The first term is itself a product, right? So how do I differentiate the first term? I differentiate the first one and keep the second one fixed. So I get e to the x cos x plus the derivative of the second term, and I keep the first one fixed. What's the derivative of the second term? Minus sine x times e to the x plus, what you can do here is that you can split the product, right? You can expand that, and you have two more products. But let's not do that. Let me take the derivative of x. What's the derivative of x? 1 times the second term plus I keep x fixed and I differentiate the second term. What's the derivative of the second term? It's cos x plus e to the x. Let's double check. Do I have something that cancels out nicely? Not something that I can see. No, I think this is the nicest way you can write it. Okay, great. So practice this and see you.